Okay guys, today we're going to be looking at Box and Whisker Plot, which again should be reviewed for you guys. You should have done this back in Algebra 1, but a Box and Whisker Plot displays the median of a set of data and the median of each half of the data and the highest and lowest data values. So, a Box and Whisker Plot is really, guys, just a good way to analyze different sets of data. So there's different parts of a Box and Whisker Plot that can help you analyze sort of what's going on. So one of those is a quartile. So there are 4 quartiles because you guys know that quarter means 4. So a quartile is a value that splits the data into 4 equal parts. So each quartile contains 25% of your data. So even though they don't look like they're the same size, 25% of that population of data is in each of those quartiles. Next one is the lower extreme. The lower extreme is the smallest data value. So when it's in order from least to greatest, the lower extreme is the smallest value. Lower quartile is going to be quartile 1. And that's going to be the median of the lower half of data values. So when you split your data in half, you find the middle. Whatever the median is of that bottom half or that first half is going to be quartile 1, or your lower quartile. The median you guys already know how to find. That's just the middle value of your data. And the upper quartile, just like the lower quartile, once you find the median and you split it in half, the upper quartile is going to be the median of that second half of data, or the upper half of data values. Upper extreme is just the highest data value when it's in order from least to greatest. And then you guys have inner quartile range. So inner quartile range is the difference between Q3 and Q1. So you guys may remember what a Box and Whisker plot looks like, but it looks something like this. So you would have your Q1, Q2, and Q3. So the IQR, which is what inner quartile range is short for, or IQR is short for, is the difference between Q3 and Q1. So it's this section right here, and that's going to be 2 quartiles, 2 sections. So this section plus this section equals 2 quartiles and equals 50% of your data. So that's where your inner quartile range is. And then you guys have an outlier, which is a data value numerically distant from your other data values. Now, you can't just say, oh, that data value looks pretty far away, so that must be an outlier. There is actually a formula that you guys have to find. So your outlier formula is going to be in this box here. And it is Q1 minus 1.5 times your IQR. So in order for you guys to be able to find if you actually have an outlier or not, you need to be able to find your IQR, so Q3 and Q1. So when it asks for an outlier, you can't just say, oh, that data value looks pretty far out there, must be an outlier. There is actually a formula to use. An outlier from the bottom half, you're going to do Q1 minus 1.5 times your IQR, and find it if it's an outlier on the top half of your data, you're going to do your Q3 plus 1.5 times your IQR. So we're going to try and look at some examples here. So I'm going to do number 1 all the way through with you guys.